Hi, this is the recording of yesterday's webinar from my AI community. In this session, I explained what long-term memory for AI agents is, why it matters, and why you should start building it as early as possible. I also showed how to install it, and then did a live demo of how it actually works. Every week inside my community, I break down a new topic around AI agents. If you want to join, message my agent through the link in the description, and it will explain everything. Enjoy the webinar. First, we will start with the theory, why this matters. And honestly, this is one of the most important parts of agentic systems, memory. Today, I want to talk about something that, in my opinion, will become a required part of working with AI, long-term memory. We already use ChatGPT, Claude, Codex, Cursor, Copilot. The next stage is agents that do not just answer us, but actually work for us. And those agents will need memory. Right now, we keep repeating the same things again and again. For example, I write in TypeScript. In this project, we use Fast API. Do not touch billing. I like short explanations. Use this library. Do it this way. All of that is not intelligence. It is context. The problem is that today we carry this context by hand, just so the agent can remember what we have already discussed. Many people already have what they call a second brain, for example in Obsidian, but that is memory for a human, not for an agent. An agent cannot use it directly very well because the amount of data is too large. It needs a separate layer where information has already been cut into useful pieces, indexed, made searchable by meaning, and can be quickly inserted into the context window. I think memory is the thing that will lock most users into AI providers. Today people argue about which model is better, ChatGPT, Codex, Gemini, Claude, DeepSeek. But models will change. Interfaces will change. The sticky thing is memory. If an agent has spent 2 years learning how to work with you, if it knows your projects and your habits, you will not want to leave, even if a better and cheaper agent appears. This will become a real problem. Imagine that you have worked with Claude Code or Codex for 2 or 3 years, and it works incredibly well. It works well because it already knows you. ChatGPT already has memory between sessions. Codex is getting memory. OpenAI has been working on a memory system that can remember much more deeply across products, including Codex and Claude Code-like workflows, and recently they made it much cheaper to run. That means they can now turn it on at much larger scale. And yes, it is convenient. But then, 2 years from now, a new agent appears. It is 10 times cheaper, and it fits your tasks perfectly. You move there, and suddenly the problem is obvious. Your old Codex or Claude Code already knows everything about you, and this new agent knows nothing. The memory that lives inside the provider will not be exported to you in a useful way. Of course it will not. The providers of intelligence want you to stay with them, keep paying them, and ideally, never leave. I do not think agents or AI are going away. The only people who will be able to live without AI are probably the same people who can live without the internet today. Everyone else will use it. And this has already started. ChatGPT has memory. OpenAI openly says that memory is needed to personalize answers and stop you from repeating yourself. Claude Code has memory-like mechanisms, such as Claude.md, automatic memory files, and project instructions that load at the beginning of a session. There is also memory.md, which can live locally. I do not know exactly how Claude Code stores everything right now, or how much external memory lives on their servers, but I am sure they will store memory between sessions much better and much more broadly than what we have in local files today, and memory is extremely convenient. If the agent remembers how your project is structured, it makes fewer mistakes. If it remembers that you prefer short answers, it answers better. If it remembers previous decisions, it stops suggesting the same thing over and over again. So the problem is not memory itself. The problem is where that memory lives. Provider memory is convenient. You do not need to set anything up. You do not need to think about it. It builds itself, but it is dangerous to become dependent on one provider. Subscription prices and subscription rules will change. Maybe it is not slavery, but it is a very strong lock-in. The formula is simple. Convenient today, expensive tomorrow. If you build your own external memory, it is less convenient today. But you stay free. You can move between agents in the future. You are not tied to one company. If a better offer appears, you can just switch. We are already moving toward usage-based billing, where you do not pay only for a subscription, but for actual API usage. GitHub has announced that Copilot plans are moving toward GitHub AI credits. Usage is counted by tokens and by model API rates. For some Copilot users, the bill has already grown 10, 20, even 30 times. Some people are canceling. Others are forced to pay much more. And this is logical. Agentic work is expensive. It is multi-step, long-running, and context-heavy. But for users, it means one simple thing. The rules will change. If all your memory is inside one provider, you have less freedom to leave. The same applies to Codex and Claude Code. Sam Altman said in March, if I remember correctly, that the future is people paying for intelligence like they pay for electricity. You pay for what you consume. Starting June 15th, Claude Code will count automatic actions through API usage. For example, an email arrives, an agent reads it, processes it, sends you a summary, or forwards it somewhere else. Or a morning summary runs automatically. Any automated action like that will be billed through API usage, not through the normal subscription. The subscription remains for the case where a human is sitting there as the operator. Everything else moves toward API credits. Codex will eventually move in the same direction. Right now, there is a race for users because only a small number of people in the world are really using agents so far. The market is still huge, so subscriptions will stay for a while. I think they will exist in some form forever, but they will get more limited over time. More and more actions will become API-build actions. Today, it may still feel normal that you sit there as the operator, but soon agents will read your messages, reply, plan things, book appointments, resolve support issues, or deal with something like sneakers you ordered that never arrived. It will feel strange for a human to do all of that manually, and those actions will not be paid for by a flat subscription. They will be API usage. In my estimates, API usage can be around 30 times more expensive than a subscription for the same amount of work. If a $20 monthly subscription gives you a certain amount of work, the same work through API billing can cost $600. The ideal architecture is this. Agents change, memory stays. Today you use Claude Code, tomorrow you use Codex. The day after that, Cursor, or some new agent with a better offer. But all of them connect to the same memory layer. Then you do not start from zero, and you stay free to choose. There are several ways to build this. Personally, I am building my own full memory layer. It collects data from everywhere. Telegram, all my agent sessions, Obsidian, published posts, YouTube, and other sources. Everything is saved and processed. But building the whole thing from scratch is hard. I have been working on this specific part for about 3 months, and it still does not work the way I want. But there are open source solutions that you can take and connect very quickly. They may not be perfect, but you do not need to build everything from zero, and you can keep it on your own computer. Today, we will look at one of those tools. The tool is Mem0. It is an open source memory layer for agents that you can install today. The simplest way to explain it is this. Add means remember. Search means recall. Everything else is implementation detail. Your agent, whether it is Claude Code, Codex, or something else, gets tools like write to memory, search memory, and recall from memory. We will test this live today. When we send text into Mem0, it does not have to store the whole text exactly as it is. It extracts facts. For example, I work on a Mac. I prefer TypeScript. I do not like long answers. That can become 3 memory records. The user works on a Mac. The user prefers TypeScript. The user likes short answers. Then those memories are embedded and stored. Embedding means the text goes through an embedding model so it can later be found by semantic search. Not by exact word match, but by meaning. So where does the LLM work here? There are several roles. The main LLM answers the user. That is your agent, Claude Code, Codex, or something else. Inside Mem0, an LLM extracts facts. The embedding model is not the same as the LLM. It turns text into numbers. Then the vector database searches for similar meanings. You can think of it as 3 roles: an editor, a translator into coordinates, and a librarian. Before the agent answers, it can search memory. For example, what are this user's coding preferences? Mem0 finds the most relevant memories and returns them. Then the agent inserts those memories into the prompt, and the model answers with that context. Mem0 has 2 main options. You can store memory in their cloud and pay them for the platform. We will look at pricing later, but the idea is simple. On the platform, you can start in minutes. You get API access, MCP integration, and less infrastructure to manage. But I installed Mem0 myself before preparing this webinar. Maybe it was not literally 3 minutes, but the agent did almost all of it. While I was making tea, it installed everything, so I cannot say that self-hosting this is especially hard. You give the task to an agent. After the session, I will send the exact prompt you can give to your own agent. It will download and configure everything. But the main theme of today's webinar is control over memory. The memory should stay with you. So it makes sense to look at self-hosting on your own computer or your own server. Mem0 itself compares the hosted platform as the managed option and the open source version as the self-hosted full control option, where you choose the vector database, the LLM, and the configuration. So how much does it cost? On the platform, you pay for memory operations. The free tier is enough for tests. We will open the site and check the exact pricing tiers in a moment. With self-hosting, you do not pay Mem0, but you still pay model providers. To embed memories, you need a model. That embedding model can also be self-hosted, but usually it is very cheap. If your system is not working around the clock, it may be only a few dollars per month. But it is not completely free. There is still intelligence involved, and that costs something. The memory has to be stored, maintained, embedded, searched, and updated. I am optimizing my own system right now. At the moment, it runs mostly through subscription agents, not direct API usage. Before optimization, if I had paid API prices, my system would have cost around $70 per day, but that was a much larger setup. It used to have around 19 agents. Now it has about 8. They were constantly thinking, someone wrote to us. How is this related to existing projects? Should this update project memory? Should we add links between facts? Should some facts be forgotten? Without intelligence, memory becomes garbage. It turns into a pile of noise. Mem0 also uses intelligence, but much less of it, so it is much cheaper. You do not need super strong models for this. You can use the OpenAI API. You can use the DeepSeek API for the LLM part, which will probably be cheaper. OpenAI's recommended model here is something like GPT 4.1 mini, which is also cheap. But there is one important detail. The LLM that understands and extracts the memory, and the embedding model that turns text into vectors, are different models. With OpenAI, you can get both through one key. DeepSeek gives you the LLM, but not the embedding model. So if you use DeepSeek for the LLM, you still need embeddings from somewhere else. You can run embeddings locally if your machine has enough resources. You can run them on your own server. Or you can still use OpenAI just for embeddings. But again, embeddings are usually cents. They are cheap. The practical approach is simple. Use it for a week. Look at the real cost. Then decide whether it is worth moving more of it onto your own computer or whether the API cost is so low that it is not worth optimizing. Now let's look at the platform pricing and then move into the live demo. How to install this, what the pricing looks like, and how it behaves with real agents. This is the Mem0 website, mem0.ai. You can use their hosted platform, but today we are mainly interested in the self-hosted option. With the hosted pricing, you are not paying model providers directly. You pay Mem0, and they store the memory for you. That is still more flexible than keeping memory inside one model provider because Mem0 can work with Claude Code, Codex, and other agents. But you still do not have full control over the memory. They also have a free plan. At the moment, I see 10,000 requests and 1,000 vector requests. Paid plans start at $19 per month. Personally, I think that is a bit expensive for this use case, because depending on usage, self-hosting should be cheaper. For the open source installation, they have a GitHub link. In practice, you can give that link to your agent and ask it to install Mem0. I will also share the full instruction prompt after the webinar. You can give that file to your agent, go make tea, come back, and if you have already granted the permissions, it should be working without asking you before every action. To install it yourself, you will also need an OpenAI API key. Go to platform.openai.com, open billing, add balance, and create an API key. $5 should be more than enough for testing. I think $5 is also their minimum top-up. Then you put that API key into the project. You can paste it directly into a chat with Codex or Claude Code. I sometimes do that, but you should understand the risk. If you paste an API key into the chat, it is sent to OpenAI or Anthropic servers. Many people do this, and providers try to prevent secrets from ending up in training data. But the risk is still there. You are giving your API key to the provider. In theory, sometime in the future, a key could leak into a dataset and appear in another user's output. So the safer way is to ask Codex or Claude Code, tell me exactly which file I should open on my computer and where I should paste the OpenAI API key. Then put the key into the local.env file instead of sending it as chat text. Now let's switch to Codex. I already gave it the Mem0 setup while preparing this. I will not show the full installation process because the installation process is basically give the agent a prompt. I will share that prompt separately. What matters now is how it works. Let's write a test memory. I will say, I really love surfing. That is not true, but for the demo it is fine. Right now we have Codex open. After that, we will check whether the same memory is visible to Claude Code. I wrote that I really love surfing. Let's see whether it saves it immediately or asks for confirmation. It saved it as a stable personal interest. Now I need to switch so you can see Claude Code. This is a completely different agent. Claude Code and Codex are not connected to each other directly. Let's ask Claude Code, what do I like doing by the sea? It checked Mem0. The first agent wrote the memory into Mem0, and this second agent read the memory from Mem0. It answered, according to my memory, you like surfing. We wrote that in a completely different agent just a moment ago, and it was saved through Mem0. This is not only memory between sessions of the same agent, it works immediately between different agents. It does not matter whether we use Claude Code or Codex. The memory stays the same. The agent already remembers that we like surfing because we talked about it. And we can inspect this directly. The memory itself is stored in a vector database called Qdrant. The agent installed that too, based on the instructions. In my case, the dashboard is available on localhost on this port. You can simply ask your agent, how do I open the dashboard, and look at the memory. There are collections here. You can open them. The format is not really designed for a human reader, because this memory is for the agent, but you can still inspect it. Here we can see the record that Nikita really likes surfing. It is stored as a stable personal interest that may be useful for planning rest, energy, and lifestyle. One more thing to understand. In the current version, Mem0 does not only save new memories, it also has a mechanism for updating and deleting old ones. For example, if I now say that I no longer like surfing, or that I have a new hobby, the newer memory becomes more relevant. Let's test that. I wrote, "Actually, I do not like surfing anymore, and I do not go to the sea at all." What happened? The agent called the memory deletion tool removed the old record and added a new one. Now let's check Codex again. We just told Claude Code that we no longer like surfing. Codex knows that too. It knows that we no longer surf and do not go to the sea. The agent calls these tools by itself. Write a fact, search facts, delete facts from memory. And this is the point. Your memory is stored locally, or on your own computer or server, and it can be connected to any agent.